Howdy pre-calc kids. Today we are going to look, not pre-calc, the vectors threw me off, guys. This is geometry. 8-5, vectors. Okay, first question, what's a vector? That's a quantity that shows a direction and a magnitude. Okay, so it does, this is your good old XY plane. And if you had a plane, they look something like this. They have a magnitude, which is a fancy word for length. They have a direction. You know, this one's going this way. Okay? Vectors are used a lot for airplanes, like when they fly. They say they go from here to here, that's a vector, right? It's a length with a certain direction, northeast, northwest, something like that, right? So that's used a lot in for waves, for liquids. Liquids travel in vector fields. Well, there's a bunch of vectors that say if I spill this, it goes out in these directions that far. Okay? Actually looks like an egg. It's radiating heat. Anyway, let's just jump into this. Okay, let's take a look at this vector guy over here. How's it going, Mr. Vector? Oh, that's fantastic. What is the vector at the right as an ordered pair? Round the coordinates to the nearest tenth. Okay, this is where we get to use some trigonometry. This is 10 degrees. This is 312. Watch this. This is really crazy, guys. Right triangle. What? Okay. I'm going to call this side X and this side Y. So those are going to be my X and Y coordinates. Now, my 312 is my hypotenuse, right? My Y is opposite. My X is adjacent. So I need to use my good friend Hokoponus SOHCAHTOA to find X and Y. Okay? Now to find Y, what writes up is sine of 10 degrees equals my opposite, which is Y, or my hypotenuse, which is 312, right? Times both sides by 312, and I get about 54.2 with my Y. Okay? Now for X, we're going to set up a very similar equation. But this time we're going to use cosine, right? That's my adjacent, my ka. So cosine of 10 equals my X over 312. Same steps. Times by 312, times by 312, and I plug that into my calculator. Beep boop 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 boop. Wolfram alpha. And you see, I already did it once. If you guys haven't discovered Wolfram alpha, you're missing out. 307.3. We get 307.3. Okay. So my coordinates are 307.3, comma, be careful, if this was my XY plane, which it is, that Y and X are on the negative side. So it's negative and negative. If this vector was over here, they'd both be positive, but it's not. It's over here, okay? Be careful. That's a B. Be careful. Alright, this one. What is the direction of the vector at the right? Is there another way you can describe it? Okay. So here's west, right? But now we're going 60 degrees away from west, and we're going south direction. So we are 60 degrees south of west. 6 degrees south of that west line, right? B. There has to be another way. Well, there is. If this angle is 6 degrees, this guy would be what? If you say 30, you are correct. Because they're complementary, and I compliment my wife to make things right. So could have also said 30 degrees west of south. Both work. Just the one that's the of, or what you can't, the line that you're starting at is going to be your second part, okay? And then which direction you go will give you the part in the front. That's so confusing. Just look at it, guys. If you have questions, ask me. An airplane lands 246 miles east and 76 miles north from where it took off. What is the magnitude and direction of its flight vector? Whoa. I always make an XY coordinate. Never eat soggy waffles. So we land 246 and 76 miles north. So this would be about what my vector looks like. Airplane noises. Now we need to find magnitude and direction. Okay. Magnitude is a fancy word for length. So we need to find the length of this beast. But watch this. Right triangle, right? This height is 76 from over here. Length is 246 right here. I can use Pythagorean theorem to find this side, which is my magnitude. I do 246 squared plus 76 squared equals x squared, right? I grab my handy dandy calculator, Wolfram Alpha, 246 squared plus 76 squared. 66292. 66292. No, tartar sauce. 292. Square root both sides. It says approximate. Approximate means we get to round, guys. Woo! Rounding. How do you square root 66292? I'm gonna blur your guys' mind. Jeopardy. 257.5. So it's 257.5. 5 is our magnitude. Okay. Now for direction, direction is a fancy word for what's the angle. Okay, so we're looking for theta now. Now we get to use our good old-fashioned trig. Now 76 relationship with theta, that's our opposite, right? 246 is our adjacent. We're going to use tan. Tan of theta equals my opposite over my adjacent, right? Now, do you guys remember how to get rid of tan? That's right, tan inverse both sides. Okay, and that'll give us our theta, which is 17.2 degrees. Okay, and that's it. That's our direction and our magnitude. And by the way, I better label this. That's miles. Okay. Phew. Nice one. B. Can a vector have negative attitude? No. distance is never negative. Okay? There's no such thing as negative distance. So no. Adding vectors. If you're adding vector A, which is x1, y1, vector C, x2, y2, A plus C equals, well, your x plus x, then your y plus y. It's actually pretty easy peasy lemon squeezy. There we go. So what is the resultant? That's a fancy word for sum of 2, 3, and negative 4, negative 2. If you haven't noticed, these little bars here, that means it's a vector, not a point. Okay, a point has parentheses. These have those. This means vector. Because look, little tiny vectors. So for my resultant, here's what I do. I go 2 plus something, then 3 plus something, right? And then I use my second point to find out what those are. So I put negative 4, negative 2. So my answer is negative 2, 1. That's it, guys. I hope you enjoyed vectors as much as I did. So now go blast off into space using a vector of magnitude, the sun. That makes sense.